Right, in this video, I'm going to try to really quickly explain why the integral from negative pi to pi of sine squared x dx is equal to pi. It comes down to these formulas that are these power reduction formulas. You can prove them, but it takes quite a bit of time. So instead of proving these formulas, I'm going to give you an argument as to why they should be true, and I'm going to do it visually. I'm only going to do it for the sine one because the cosine one will work once I make my sine squared argument. So notice here, sine squared x is equal to 1 minus cosine of 2x over 2. Intuitively, you may be like, say what? But let me show you why it's true. Okay, so notice I've got a sine graph here. Notice sine goes from -1 to +1. So I'm going to try to visually think about what squaring sine would look like. Well, I know that it's going to make all those negative pieces positive, right? So when I square this negative thing, it's going to become positive. The other thing that I know that's going to be true is that anything between 0 and 1, if I square it, it's going to stay between 0 and 1. Think about 0.75, 3/4 squared. When I square that, I get 9 over 16. That's between 0 and 1. Anything between 0 and 1, when I square it, is going to remain between 0 and 1. So when I square sine, it should have a shape that is similar to this. And in fact, I will just write sine squared of x like that. Boom. And you see that, right? So it takes that absolute value thing and sort of smooths it out a little bit, right? You see this thing goes like this. And I've got this periodic nature. The pieces that matter a lot here are this dot and that dot and that dot. Notice the high points, wherever sine was 1 or -1, I should say, wherever sine was 1 or -1 down here, the sine squared is going to be 1. And then wherever sine is 0, sine squared is going to be 0. So it should make sense that this point is here, and this point is here, and this point is here, and this point is here. And then what I need to do is get a smooth curve that sort of follows the absolute value of sine of x. So hopefully it makes sense that this is the general shape of the sine squared x. Now what I need to do is figure out an equation that will fit that. So I'm going to actually turn this one off. Notice the green graph is actually a sinusoidal graph. What does that mean? It's a sine or a cosine curve that's been shifted up or down, maybe a little sideways, right? The amplitude has changed a little bit. That green graph, and you can see it there clearly, is also a sinusoidal graph. It is a sine or a cosine curve. So the question becomes, what is the equation of that thing right there? So what I want you to see, if I put this thing back up here, this has a period of 2 pi, the original sine graph. Notice this green graph begins to repeat itself here. So what does that mean the period of the green graph is? It is pi. So I need to have a different number in here for my omega that defines the period. So I'm going to add a new thing here. The other thing that I want to point out before I add something here is that this green graph starts low and then it goes up, right? If I think about a sine graph, at 0, the sine graph is at the central point of the oscillations, right? So it oscillates up and down and up and down, and this y value at the starting point is at that center point, at 0, right? It has a height of 0. Whereas this thing oscillates around a half, right? The green one oscillates around a half. So, and it starts down below. So what that means is that this thing has to be a cosine graph. And if I make it a cosine of 2x graph, notice the purple, it's getting kind of jumbly here, but the purple has the same period as the red, and I will turn, or sorry, as the green. Look, this starts up at the high point, goes down, and then back up, and this starts at the low point and goes up and then back down. So you should see that I just need to change the stretch factor and then potentially move the green graph up and down. So notice the amplitude of the, I said green a moment ago and I meant to say purple. The amplitude of the purple graph is twice the green graph. So if I do 1 over 2 times that thing, then they have the same amplitude. And if I put a negative out front like that, you can see that I now only need to shift this up and down, right? So what I'm going to do now is add, what do I need to add? This thing is down, it's at 9.5. So I just add 1/2, and boom, they land on each other. So the green graph and the purple graph are the same. And that is my identity right there. It's 1/2 minus, it's 1 minus cosine of 2x all over 2. This right here is the same as what I have here. And that's the identity. We could go through a really long process to do this, but hopefully this at least visually makes sense. Remember, sine, if I square it, it's between 0 and 1. Then it's going to have to be, the square of sine has to be between 0 and 1. So it's kind of like taking the absolute value there, right? That blue one. So in order to get the green one, I just need to have a smooth version of that. Well, what's a smooth version of that going to be? Well, it's going to be a sinusoidal curve as well. And this is it's an okay visual argument for why sine squared is this. Why I get this identity right here. Cosine squared, I could do the same kind of argument. One way to think about that would be the loops, the oscillations of the red graph are just shifted a little bit left and right for a cosine curve. So if I square it, then the shape should just be a shifted shape of the sine squared graph, which is why I get the plus cosine 2x. It's just a way to change it. So from there, I need to integrate this thing. I need to show that the integral from negative pi to pi of sine squared x is pi. So that's actually a pretty quick calculation if you know how to do definite integrals. I'll come down here. I already have it pre-written for us. I got integral from negative pi to pi of sine squared x. There should be a dx there. All I did was sub in my identity from above right here. I wrote 1/2 minus cosine of 2x over 2. That's equivalent to this fraction right here. So from there, I integrate. I get x over 2. I get a negative sine of 2x over 4. The 4 comes from a little bit of chain rule with this right here, or u sub, however you want to think about it. And then I evaluate it. So I got pi over, well, let me talk about these guys. Well, it's just these are plugged in there. The sine of 2 pi, which is this plugged in here, well, sine of 2 pi is 0. Sine of negative 2 pi, also 0. So this guy is 0, this guy is 0. I just do this minus a negative that, which is pi over 2 plus pi over 2, which gives me pi.